All right, so we're starting with 4.1 of systems of linear equations. I accidentally wasn't recording the screen when I was talking previously, so this is where the video is starting now. So we're just doing an example from the review, and that's going to be solving these equations, right? So we have decided to use elimination method because if I use a substitution method, it's not going to be nice numbers, unfortunately. So I'm going to do elimination. I'm going to pick the X variable. So I'm going to isolate this variable right here, the X one, or eliminate it, sorry. So I'm going to multiply both sides by, 2 times 5 is 10. So I'm going to multiply this by -5, and then this by -5, and I'm going to multiply this by 2, and then multiply this by 2. And again, you could do it the other way around where it's like 5 and -2. It's kind of up to you. Okay. And then you're just going to multiply across, and you're going to get -10x minus 6y equals -5. 10x plus 8y equals 12. Okay. From there, you're going to add them together, and the first column cancels out, as it should. And then I'm going to get 2y equals 7. Okay. Are there any questions on that step right there?
Yeah, in the first equation, wouldn't it be -15y?
15y. Oh, yes, you're right. Sorry. Good catch. So then it's going to be 7y negative. No, you're right, because I thought 2 times 3 in that problem. Yeah, that happens. So it's -15 plus 8y is a -7. And then did I do everything else correctly? Yes. Okay. So then in this part, y is equal to a -1. Okay. Any questions? Good catch on that. So now we can solve for x. Let's solve for x. So pick whatever equation you want. So I'll do the first equation, 2x plus 3y equals 1. 2x plus 3 times -1 equals 1. 2x minus 3 equals 1. 2x equals 4. X equals 2. Right? And then your final answer should always be a coordinate where it's x comma y. So you should always write your answer as a coordinate. Any questions on that? So we'll do one more just to see, what happens when I get the infinite solution case. Like, how do I deal with that? And we'll practice. Like I said, if we don't ask you to do one of these problems, if we ask you to solve an inequality, you still have to use these techniques, because part of the technique of solving inequalities is to make them equal and then solve. Okay. So either way, you're still going to have to use the same technique. But any questions? I'm just going to copy over the next one. And I do post, I'm going to post these PowerPoint slides with the video, so you will have both access to them. All right, example. So solve 4x minus 8y equals 20. And then 2x minus 4y equals 10. So because this is a 2x2 system, it's actually going to be, it has to be kind of obvious that it's, twice as many. A 3x3, you could hide it, but with a 2x2, it's actually impossible to hide, honestly. So if you look at both equations, you notice that one is a double of the other. Okay, but still, I'll use elimination method. And like I said, most students prefer elimination method anyways. Like that. And then 2x minus 4y equals 10. Now in this problem, I only need to change one of the rows. So I'm going to change the bottom row, and I'm going to multiply it by -2. I would never divide, just because you don't want fractions. Are there problems where division you can do? Yes. But generally speaking, multiplication is always more desired. And so I get that. I get -4x plus 8y equals -20. And if I add them together, I get 0 equals 0. So this is what we call the infinite solutions. Okay. Now, if I ask the question, how many solutions are there? You would just say infinitely many. But if I say, what is the solution? Then you would have to solve for one of the variables. Okay. So in the directions, they actually say solve in terms of X. So in the directions, they say in terms of X. So that tells you, okay, I need my final answer to be as a function of X. So what you're going to do now is take an equation. Okay. Sorry. Take the variable y and set it equal to X. Okay. Then plug into either equation and solve for X. Okay, so let me give you a quick second. Personally, I prefer using a different letter like T, but in their example, they just actually, sorry. Like I said, I'm not used to using the letter X. I use T. So take the variable y. Let me rewrite this because I want to write this I'm going to write this in a much simpler way. Sorry. Take either equation and isolate y. Because if you isolate y, it becomes a function of X. So it doesn't matter which equation you take, 2X minus 4y equals 10. You just have to isolate y, so that becomes your function of X. So I'm going to subtract over the 2X. It's like a negative 4y equals minus 2X plus 10. I'm going to divide both sides by negative 4. And so I get y equals negative 2x, which becomes a positive 1/2, plus 10 over 4, or 5 over 2. Okay, but it is a minus sign because positive and negative. So our solution is x comma y, but y is equal to 1/2 x minus 5/2. So this is equal to x comma 1/2 x minus 5/2, like that. Okay. Like I said, personally, I use a different letter. I use T usually, but in this problem, they don't. Okay. Are there any questions on that? So if they tell you to solve it in terms of y, then you would solve for x in the previous step. But because they ask us for a function of x, your final answer should only have x. Okay. Are there any questions on that? So, I mean, those were the third example on the homework is the infinite solution case, sorry, the no solution case. So we can just do that one because, I mean, or actually, no, we'll do the word problem. But if you run into the no solution case, it's just gonna be like, you're gonna get like 0 equals 5. Like you're gonna get two numbers that don't match. So no solution is when you get something like 0 equals 5. Okay, that just means you have no solution. Any questions? Just want to make sure before we move on. All right. So let's move on to linear programming. Okay. So 6.1 slash 6.2 linear programming inequalities. Okay. So just give me 1 second and I'll be right. I just got to get a quick drink. Oops. So actually, I didn't see the problem. There was a word problem. Let's do that together for 4.1, just so that we can set up the word problem. Sorry, I didn't see it, but now I did. So we're going to do number 2 together. So the ice cream problem. There's one very similar to this on the homework. In fact, I think it's the exact same thing. So we'll just practice up, because just as important for you to be able to solve these, you have to be able to set them up. So the setup is equally as important as the solving, right? So you're making 2 ice cream flavors. You got vanilla and mocha. You know, vanilla uses 2 eggs and 3 cups of cream. And then mocha uses 1 egg and 3 cups of cream. So you have 550 eggs and 1050 cups of cream. So how many of each quart can you make, right? So this problem students struggle with just setting it up. So basically, one way to think about it is you got to define your variables, right? So, you know, first thing you want to do is define variables. So eggs are not going to be your variables because you know how many eggs you have and how many eggs you need to use. Cups are not going to be your variable because you know how many cups of cream you need and then how many cups of cream you have, right? So my variables are going to be the quart of vanilla, and then y is going to be a quart of mocha. Okay, does everyone see that? So step 2 is to make equations. So this is the part where students struggle a little bit, but you're going to have to think about it. You have 2 things that you're focusing on, eggs and cream, right? So you're going to make an equation for how many eggs you're going to use, and you're going to make an equation for how many cup of cream you're going to use, right? So for the eggs, I use 2 for my vanilla plus 1 for my mocha, and that is equal to the 550 eggs that I have. So this is my egg equation. Does that make sense? So what a lot of people kind of confuse is like they're trying to make a quart equation, but you're not making the quarts. You're making so you're not making like eggs and cream. You're making quarts. So the quarts are the variable, and then the numbers are the number of eggs and cream. And then so for the vanilla, I use 3 cups of cream plus I use 3 cups of cream for the mocha, and I have 1050 of those. So these are the cream. Any questions on that, how I set up these equations? So once you get that part, now you just have to solve it, right? And so step 3 is to solve. So we can use elimination, and I will use elimination. So 2x plus y equals 550. 3x plus 3y equals 1050. Now, the y, notice that the y is by itself. So that's good because now I just got to only change one equation, and I'm going to multiply by -3, like that. And so I get -6x minus 3y equals -1650. 3x plus 3y equals 1050. And realistically, if you're doing a problem like this, you should get nice numbers. If you don't get nice numbers, I would double check your math because you're not really going to have like 3/4 of a cup. You should have like nice measurements with, you know, in general. So -3x equals, what would that be? -500. Sorry, not -500, -600. Another way that you can tell that you're on the right track, this usually happens. you'll have a negative on the both sides, or positive, right? That happens a lot. So then x is equal to 200 eggs. Sorry, not eggs. That's my fault. So x was the quarts of vanilla, so vanilla. I should put quarts. And then now I just need to solve for y, so the number of quarts for the mocha, okay? But are there any questions so far? I just want to make sure. So I'm going to create a new slide, and then so x is equal to 200, and so sub into equation to find y. So I'm going to take equation number 1, the egg equation right here. So 2x plus 1 y equals 550. So 2 times 200 plus y equals 550. 400 plus y equals 550. Y equals 150 quarts of mocha. And that's my answer. So it was 200 quarts of vanilla, and then 150 quarts of mocha. Any questions on that problem? I just want to make sure. All right. Okay. So for the next problem, I'm just going to pull one up from the homework because the exam doesn't do one, or the review doesn't do one exactly like this. I just want to practice this specifically. Okay. So now we're going to do 6.1-6.2. Okay. So this is the example we're going to do from the homework. So sketch the region of the given inequalities and then find the correct solution set. Okay. So, and I'll keep saying this, when you're studying for this exam, know the fundamentals, know how to do the ones that aren't complicated. You know, this is a less complicated version of like the ones where there's like 5 or 6 constraints, right? If you know how to do these ones first, then the other ones become a little bit easier. But when it comes to doing these, focus on the fundamentals, right? We got 50 minutes to ask you however many questions, right? I can't ask you to do a complicated one because you'll run out of time to do all the other problems. So you need to think about it from that perspective too. If I do a homework problem and I really try on it and I get it correctly, and I was like very efficient, and it still took me like 20 minutes, chances are that problem won't be on the exam. But if I can do a problem in 5 minutes and I get it correctly, now that's a problem that's more likely to be on the exam for a 50-minute class. Okay. Now, if we had 2 hours for the exam, then of course I could ask you that, 20-minute question. But you got to think about that. What problems take me a lot longer? Now, you have to take it into context. If it takes you 30 minutes to do it because you're just kind of doing it slowly, that's not the same thing, because you need to ask yourself, how long would this take me to do on an exam? Could I do it in like 10 minutes if I was like really trying? Because if you can do it in 10 minutes, that's more likely to be on the exam. But if you're really trying and it takes you 20+ minutes, chances of that being on the exam are very low, unless this was like a 5-question exam, right? So you got to think about it that way. So we're doing a problem like this, right? This is not linear programming yet. This is just linear inequalities. So we just want to be able to find the solution region. So, or the solution set. All right. So step 1, convert inequalities to y equals mx plus b. So that's the first thing you want to do, right? Convert them to y equals mx plus b. So 2x minus y equals 4, x plus 2y equals 2. Okay. Then I'm going to move over the negative 2x plus 4. And then I'm going to divide both sides by a negative 1. And I get y equals positive 2 minus 4. Okay, so I got this equation. Do the same thing over here. 2y, I'm going to subtract over the x, and I get negative x plus 2. And then I'm going to divide both sides by 2, and I get negative 1/2 x plus 1. Okay. And so this would be a good chance to, use your calculator if you want. So I will open up my calculator like that. And we'll just review how to plot these in the calculator. So click on y equals, and then just plot them down. So 2x minus 4. Remember, this is the subtraction symbol, and then the bottom right one is the minus symbol. So don't get those two confused, because if you use them incorrectly, you'll either get a syntax error or you'll accidentally do multiplication. So negative 1/2 x plus 1. So I have plotted them down into my calculator. Okay. So do a zoom 6. And then now I have a nice little picture of my graph. So step 2 is to just graph. Okay. Now you don't have to graph this perfectly, but the better it looks, the better it is, the easier it is to recognize coordinates. Okay. So going back to my picture. Okay. If you press zoom 2, you can zoom in a little bit. Now, sometimes the zoom in isn't great because it might zoom in too much. But I see that they cross at 2. So if I want to draw that, this is 2. And then remember this number right here is the y-intercept. Okay. So I'm going to use different colors. So this one will be purple, and then this one will be green. Okay. So this is a 1, 2, 3, 4. So it's going to do something like this. Okay. And then this one's going to be positive 2. And then it's going to go down by 1. And it crosses like that. Okay. Any questions? So we have drawn it. Now we need to pick our test points. So we need a point in each quadrant, right? I always start with 0, 0 if possible. So the next step, I'm going to take this picture and I'm just going to copy it to the next slide so that we have it as a reference. So new slide. So here's that picture. So step 3 is pick test points to find solution region. Okay. So I am going to pick 0, 0 right here. Because I know this is 0, 2, this point right here is 0, 2. I'm going to pick 2, 1. 2, 1. I'm going to pick this one right here, 3, 0. You don't have to pick as close nearby. You just pick whatever numbers you like. And then I'm going to do, I don't know, 2, -2. So I'll do 2, -2. If you want to do one at a time, you like pick one, test it, pick one, test it. You can do that too. You don't have to actually find all 4 immediately. Just depends. Okay. Any questions though? So let's say, let's do this one first. I want to do this one first. Okay. So now step 4, plug test points into inequalities. So to remind ourselves of the inequalities, they are 2x minus y less than or equal to 4. and they are x plus 2y less than or equal to 2. Okay, so it has to satisfy both of them for it to be a solution space. So first we're going to do 3 comma 0, sorry, wrong one. No, it's doing that glitch thing. All right, sorry, let me just pause it because it's kind of glitching out. Give me 1 sec. So we just had a little glitch within PowerPoint, so I got to rewrite some of this. So less than 4. Where is it? X plus 2y less than or equal to 2. And we're going to use the point 2 comma 1. So we're going to plug it into both inequalities. So 2 times 2 minus 1 less than or equal to 4. So I get 3 less than or equal to 4, check. And then I do 2 plus 2 times 1 less than or equal to 2. I get 4 less than or equal to 2. No. So that is not a good region. Okay. Not a good region. So like I said, for some reason, our textbook, they like to shade in the bad region. So I don't know, just kind of draw some lines through it. And that tells you not good, right? Then let's say the next region, I do 0, 0. Okay. I would do 0, 0 first, no matter what, but I wanted to show you that, what happens when you don't get a good one. So if I plug in 0, 0, I get 2 times 0 minus 0 less than 4. I get 0 less than 4. Check. Oops, didn't write the 4. If I do 0 plus 2 times 0 less than 2, I get 0 less than 2. Check. So this is my solution set. And then everything else is shaded out, like it's crossed out, basically. So the region that's not shaded out is the solution region. Right? Does that make sense? I just want to make sure.
How did you pick the test points?
I just pick anything that's not on the line.
Oh, okay.
Not on line. So if you draw it very crudely, what happens sometimes is that if you don't draw it perfectly, you might pick a point that you think is in one region, but if you were to draw it more accurately, it's actually in another region barely. So that's why it's always safe to pick points that are like really far apart, just because if you don't draw it from a calculator, then you can run into that mistake, right?
So I just pick a point in each region.
Yeah. So I pick 0, 0, 2, 1, 3, 0, and then 2, negative 2, right? But I could have done, negative 1, 0, or negative 50, 0. Whatever helps you get the correct point. I just pick smaller numbers because it makes the algebra a little bit simpler. That's all.
Thank you.
Yep. Any other questions? Okay. Now, this question also says find the corner point. So there is one corner point, and that would be this intersection, right? Or find the intersection is another way I could ask that problem, right? So now here is a follow-up question. Is the region bounded or unbounded? Okay. So say whether the region is bounded or unbounded. Basically, are there lines all around or does it go to the infinities? So this is an unbounded region. Okay. Because all the spaces go to infinity. Okay. And then the next question is find the corner point. Okay. So find the corner point. So the corner point is any intersection. So because the line intersects like this, and the intersection point is at 2, 0, the intersection point or the corner point is 2, 0. Okay. Are there any questions on that? I just want to make sure. So we will do one more related to this, and then we are going to do some word problem and practice those. And then after that, we'll do partial derivatives. Okay. So again, This is from the homework. So sketch the region. Given below, and then find the solution set, right? So in this problem, you actually have 5 equations. You have 1, 2, 3, 4, and 5. You actually have 5 equations right here. So step 1, convert to y equals mx plus b, okay? Or x equals number. Because you can't convert an x equals into a y equals mx plus b. So x plus y is equal to 2, x is equal to 4, y is equal to 4, x is equal to 0, and then y is equal to 0, like that, okay? So in reality, there's only one equation I have to change, and that's this one, and that's y equals negative x plus 2, okay? So remember, x equals number is a vertical line, and y equals number is a horizontal line. Any questions on that? You do have to remember that. So x is vertical, y is horizontal. So step 2 is to graph. So I'll draw a nice little graph. And so I will use different colors. I have to use several colors right here. So this will be purple. This will be green. This will be blue. This will be orange. And this one will be bright green. It shows up well. Okay. So the bright green one, y equals 0, that's the horizontal line that goes like this. That's y equals 0. Okay. Then the orange one is x equals 0. That's the vertical line that goes down the x-axis like that. So that's x equals 0. The y equals 4 is just a horizontal line that goes through the number 4. So this would be 4. Okay. X equals 4 is the vertical line that cuts through here. So this would be 4. And this is x equals 4. And then y equals negative x plus 2. Okay. This color is going to be at 2. So this is 2. And then it goes down 1 over 1. So it has a slope of 2. So this is going to be 2 right here. And it's just going to cut through that. Okay. So like that and like that. Okay. So they're going to cross eventually. Any questions on that? Just want to make sure. So I'm going to take this right over here, and I'm going to copy it into the next slide so that we have it right here. And then I'm going to add just some extension to it. Just so that, get the dark green, crosses right there. And so let me count you how many regions you have to check. So you have this region, number 1. Make this black. 2, 3, 4, 5, 6, 7. I mean, technically speaking, I can just keep drawing it. 8, 9, and 10, and 11. That's how many different regions you could have. Okay. Does everyone see that? In fact, actually, there's another one right here, 12. Okay, 13. Does everyone see that? Like, do you see how many options you have for here? But here's the trick. Here is the trick. Okay. 90% of the time plus, it's not going to be any of the outside ones. It's probably not going to be this one, 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 and this one. How do I know that, you might ask? Well, go back to the original condition. Do you see right here that these have to be positive numbers? Does everyone see that? That means anything with a negative number is automatically off the table. I missed one right here. There's another one right here, 14. But these are all off the table, okay? So actually, let me not erase these ones just yet. So the only ones that actually have a chance are 4, 5, 6, 11, 12. These 5 right there, okay? Right now, these are the only ones that actually have a chance because they don't break the very first 2 rules that they have to be positive, okay? And then here's what I'll tell you. 90% of the time, it's going to be a bounded one, okay? It's either going to be 11 or 12, okay? So you might have, 13 options, 14 options, but the truth is the only 2 you have to test are these 2 right here. Okay, let me highlight them with a different color like green. The only ones that actually matter are these 2, because 90+% of the time it's going to be one of those 2. Okay, how do I know that? It's because that's part of the whole thing. If it's bounded, you should have a solution there. Okay, so it's either 11 or 12. So we're going to pick test points. So step 3, pick test points for 11 and 12. Now, if you're wondering, did I order it in a specific way? No, I just kind of, went counterclockwise or clockwise, but you don't have to number it in any specific way. Okay. So I'm going to pick 2 numbers. So notice that this is 0, 2, and this is 2, 0. So right here would be 2, 2. So I'm going to use the point 2, 2. 2, 2. And then this is 1, 1 right here. So this one's a little trickier. I'm actually going to do 0.5, 0.5. That one's a little trickier because it's all in a fraction zone. So you have to pick a fraction. Okay. So that's like right in the middle right here. So I'm going to test those 2 points. Okay. So let me write down all of my inequalities. Let me erase all of this. So x plus y. Also, some of you, the more you get comfortable with these, the better you can start to kind of cheat, this step. Like you don't even have to plug in the numbers. You can kind of tell just by looking at them. Sorry, wrong way. It's the other way. Notice that this equation right here says that you're above the line. So really it's going to be 11. Like that's actually going to be the answer, but let's just say we didn't notice that. So I'm going to do 2, 2. So 2 plus 2 is greater than 2. So 4 is greater than 2. Check. 2 is less than or equal to 2. Check. 2 is less than or equal to 4. Check. 2 is greater than or equal to 0. Check. 2 is greater than or equal to 0. Check. This right here is my solution region. Okay, drop arrow. So that's my solution set. Not this one. Okay. Are there any questions? But I'm telling you right now, 90% of the time, it's going to be the bounded region. Okay. You can ignore the unbounded regions, really. So give you a second to finish copying that down. And then I have 2 follow-up questions that could easily be asked for you. The next question that we could ask you is it bounded or unbounded? Is the region bounded or unbounded? And when they say region, they mean the solution region. And you say, well, it has a line on each side, so it is bounded. Okay, so each side is bounded. Then from there, they might ask you, okay, what are the corner points? So now I want you to find the corner points. So give me a second. So find the corner points. So I'm going to grab the graph again. Actually, I don't want it as a picture because I want to erase some things. Okay, so here's our graph. I'm going to erase a bunch of things that we don't need. We do need that y equals 0. We don't need all the numbering. And get rid of that. There we go. Okay. So we have established that this right here is my solution region. Okay. So now I just want to find the corner points. Now in the directions, they say from smallest to largest x. So let's just like label, we have A, B, C, D, and E. Okay. Now this problem is actually a little bit easier in that the coordinates are pretty, not, I wouldn't say, kind of obvious because they're just nice numbers, so coordinates. So this one right here is the y-intercept, so 0, 2. Okay. B is the y-intercept 0, 4. C is when y equals 4 and x equals 4, so 4, 4. D is 4, 0. And then E is 2, 0, like that. And that is the coordinates. Now, in practice, how would you do this? You would set each of the 2 lines equal to each other and solve. Okay. And we practiced that several times in class. You just set the different lines equal to each other, either through, say, the calculator, elimination method, substitution method, or just set them equal to each other and solve. Okay. And we'll practice that with the word problem. But are there any questions on the basic principles of this problem? So we're going to do a word problem next. All right, so new slide. So this is from the review. And we'll do the first part of the question like this. Set up for the solution of the linear programming problem. So the first thing we just need to practice is setup, right? So we want to set this up correctly. So step number 1, what I would do is declare variables. Okay. What are your variables? That's the first thing you want to do. So we have a parking lot, has 600 square meters. A car requires 6 square meters. A bus requires 30 square meters. The attendant can only handle 60 vehicles. If a car is charged $250 and a bus is charged $750, how many of each should be accepted to maximize profit? So first thing, let's declare a variable. So we're going to use x and y. You can use whatever letters you want, but in my experience, x and y is the best letter for most students because when you have to convert it to y equals mx plus b, a lot of students could do that more easily. So I'll do x equals cars and y equals buses. Okay. Any questions on that? So those are my variables. Step number 2 is to define your objective. What is your objective function? Okay. What are you trying to do? Well, you got to look for some keywords. So the first keyword I see is maximize. That's the word I like to see, maximize. I'm going to try using green, yellow. If that's better. Yeah, maximize. Okay. And what do I want to maximize? I want to maximize profit. Okay. So how do I do that? Well, my profit, so P, is equal to how much I charge for each vehicle. So $250 for each car and $750 for each bus. So $250 for each car plus $750 for each bus. Does everyone see that? That's what I'm trying to maximize. How much I got to take of each car and bus. Okay. So we have declared our variables. We have defined our objective. The third thing we have to do is define your constraints. Okay. So how many constraints? What are your constraints? So you got to think about what are the things that you have limitations on. Okay. Now, when you're doing a problem like this specifically, you want to think about natural constraints. And what I mean by that is these are things that in your mind, you know, is kind of obvious, but you still have to define them. For example, can you have 0 cars? Yes. Can you have 0 buses? Absolutely. Can you have -1 car or -1 bus? No. It doesn't make sense to have negative numbers for this problem. So my first constraint is I'm allowed to have 0 of each. However, I can't have negatives because it doesn't make sense, right? In this problem, having a negative amount of vehicles is just not physically compatible. So that's a natural constraint that you have, okay? So they tell us that the lot can only hold 60 vehicles, right? So that means however many of both I have to have 60 of them. So X plus Y has to be less than or equal to 60. I can't have more than that because I don't have enough space. Okay. Sorry, I don't have enough manpower to control that many cars. Okay. Then, okay, they say now each vehicle takes up a certain amount of space. So I only have 600 square meters. A car requires 6 and a bus requires 30. So I'm going to do 6 for each car plus 30 for each bus, and that has to be less than or equal to 600. Okay. Are there any questions on that? All right, so we have, I believe, all of our constraints because I'm looking and I don't see any other numbers that I haven't used. So I think I have gotten all the constraints. Okay. So this is the first question. I have my objective and I have my constraints. And then I also have my variables. You got to define your variables too, because if you don't, you will lose a point or two. Any questions on that? I just want to make sure. So now the next step is to maximize or minimize. So in this problem, they say maximize. So that's going to be part B. So we're going to maximize the problem. So now on an exam, you'll notice how the question's worded. So they say, okay, using what you did in part A, what should you do? So if you run into a problem and you don't know how to set it up, just make something up and then you can still get full credit for part B if you do it correctly. Okay. So, you know, if you're like, say you have like 5 minutes left, make something up for part A that's just, you know, somewhat true, and then solve part B correctly, and you can still get full credit for part B. So we're going to maximize P equals 250 X plus 750 Y, given that X plus Y is less than or equal to 60, 6X plus 30Y is less than or equal to 600, and then X has to be greater than 0 and Y has to be greater than 0. So those are my constraints. So step 1, convert inequalities to Y equals MX plus B, or X equals number. So X plus Y equals 60, 6X plus 30, Y equals 600, X equals 0, Y equals 0. Okay, so we're setting that up. Any questions on that? So now we convert. So Y equals negative X plus 60. Let's see, 30Y equals negative 6X plus 600. Y equals negative 1/5 X plus 20. And then X equals 0, Y equals 0. Okay, so those are my 4 equations. And so we're going to graph all of these. So it's giving us some color designation. So on the next slide, we are going to graph. The graph. So first, I'm going to graph the X equals 0 and the Y equals 0. So blue and orange. So Y equals 0. Whoops. Wrong color. Is going to be the horizontal line. Y equals 0. And then the blue line is going to be X equals 0. The purple line is negative 1/5 X plus 20. So Y equals, actually, I'll put it below. Y equals negative 1/5 X plus 20. So that means I'm going to be at 20 right here. Now I'm going to go down 1 over 5, down 1 over 5, and I'm going to keep doing that. And so basically I just draw a line. And if I calculated the x-intercept, this would actually be 100. Okay. Or if I plug that into my calculator, I would see that that's 100. If you're wondering, how did I get that number? I mean, you can also do it this way. Set this equal to 0. And then this becomes 20 equals negative 1/5 X. And then X becomes 100. So that's the x-intercept. Okay. And then the green one is negative X plus 60. So that's going to be up here like that. So 60, and I'm going to go down 1 over 1. So this one, if I set this equal to 0, then X is equal to 60. So it's going to cross at the 60 point right there. Okay. Oops, I don't want to put it right there. So this is going to be 60. So really, you have 2 regions that you're interested in. It's either going to be this region or it could potentially be this region right here. Okay. So it's either 1 or 2. 1 or 2. So we got to figure out which one it is. And I'm telling you this, 90% of the time, it's going to be number 1, the one that's hitting all the lines. Okay, 90% of the time. So step 3 is test points. So I'm going to, I can't use 0, 0 because 0, 0 is on the line, but I can use the point 1, 1. That works. And then so this is for number 1. And then for number 2, just somewhere in there. So I would do something like 61, 1. I just went slightly over and then slightly up. That's all I did. Slightly over and slightly up. And then our inequalities are x plus y, sorry, that's not a y, is less than or equal to 60. Whoops. It's not. Our other inequality is 6x plus 30y is less than or equal to 600. X has to be a positive number, y has to be a positive number. Okay, so we're just figuring out what is the test solution set, region. So 1 plus 1 less than 60. So 2 is less than 60. Check. 6 plus 30 is less than 600. So 36 is less than 60. 600, sorry. Check. 1's bigger than 0. Check. 1's bigger than 0. Check. So this is my solution region. But I'm telling you right now, like 90% of the time plus, that's going to be your solution region anyways. The one that's like the corner and it hits all of the lines that you're using. Okay. So step 4 is to label corner points. There's no, it doesn't matter how you do it, but you want to label them. So this is A, this is B, C, and D. Okay. And the maximum solution is going to be one of the corner points. Okay. So we have labeled the corners. So A, B, C. And then I'm going to create a new slide. So let me just erase some of this information that we don't need. Okay. So that was step 4. Step 5, find coordinates of corner points. Find the coordinates of the corner point. Now, sometimes it is obvious which one it is, okay? So for A, the corner point is 0, 0, right? Because it's right here. For B, it's right over here. So that's going to be 0, 20 because it's a y-intercept. D is also an easier one because it's an x-intercept right here. So that's 60, 0. Now C is the one that's a little bit more difficult. I have to figure out the intersection point of those two lines. So I have C right here. I'm going to use y equals negative x plus 60. And then y equals negative 1/5 x plus 20. Okay. Now I'll show you how to do this on the calculator if you want. So go to your calculator, turn it on, y equals. So you would do negative x plus 60 down, negative 1 divided by 5 x plus 20. And then you're going to do a zoom 6, right? Zoom 6. And you don't see anything and you're wondering, does my calculator break? No, it's just because the lines are bigger. So what I would do here is I would do a zoom out, zoom 3. Zoom out a little bit. Oh, I see one over there. And I see it over there. So what this is telling me is it's somewhere to the right. So I'm going to hit the window arrow key. And I'm just going to make my maximum a little bit bigger so I can go farther out. I'm going to do, I don't know, 70. And then I'm going to hit the graph button. There it is. Bam. Now I have it in vision. So what you're going to do is do second intersect, or sorry, second trace, go to the option of intersect. And if you only do 2 lines at a time, you just got to press enter 1, 2, 3. And there it is. That's why doing 2 lines at a time, you don't even have to move it around, just press enter, enter, enter. And so we get 50, 10. Now, if you're wondering, I don't like using my calculator. How can I do it by hand? Okay, set these 2 equations equal to each other. Okay. I'm going to add the X over and subtract the 20 over. And so what I get is on the left side, I get 40. And on the right side, I get 4/5 X. And then if I multiply both sides by 5/4, 5/4, X is equal to 50. And then I plug this into this one. So then Y equals -50 plus 60, Y equals 10. And then I get the same thing. So you can do it that way. Then step 6 is plug in. So step 6, plug into P. So remember our P equation. Actually, I'm going to do it on a new slide. So let me copy this table over. Step 6. Find max. Paste it. Oh, here we go. Line P equals, now what was our objective equation at the beginning? 250x plus 750. So 250x plus 750y. So P equals 0. If you don't take any cars, you're going to get nothing. Makes sense to me. P equals 0 plus 750 times 20. So if you only take buses, okay, and you might think, well, if I take all of the high paying cars, maybe I'll make more money. So I only take buses. You get 150. And then someone else says, hey, what if I only take cars because I can fit way more cars into the lot than I can buses? Is that better? So we do 250 and then plus 0. And so someone uses the reverse logic. So 250 times 60. And nope, we end up making the same amount of money. So if I do all cars or all buses, I still make the same. So then someone says, okay, we're going to do 50 cars and then we're going to do 10 buses. And let's see how much we make. And we make $200. So P equals 250 times 50 plus 750 times 10, and it's 200. So generally speaking, when you're maximizing profit or revenue or cost, it's usually not the endpoints, okay? Like the extreme concepts, like all buses or all cars. It's always somewhere in between, most of the time, okay? But it just depends. Are there any questions on this problem? Okay, I just want to make sure. So if you can do this example, then you're on track. This is kind of what you want to be able to do. Okay. Any questions? Because now we're just going to practice partial derivatives. All right. So so this is the end of the recording for 4.1 to 6.2. I will now do a recording for the partial derivatives separately.